So for this question from Chapter 16, we are given a density function that we need to integrate, and we're involving the xy, the yz, and the xz planes with this as our equation of the plane. And since it's bounded by x, y, x, z, so those are going to limit us. So we're going to integrate x to the 7th. We're going to do a triple integral, and noticing that this one, it will be easiest to solve for z. That's where I will start. You could use the other ones first, but I'm going to go with dz, and then it doesn't really matter, but I'll go with dy and then dx. To find the limits, what we do is we first find this function, because these x, y, yz, so think of those as the, or to draw in 3 dimensions, but think of those as the axes, x, y, and z axes. So each of them being equal to 0, the xy plane is where z equals 0, and then where it would intersect the x-axis is where y would be, both z and y would be equal to 0. So we kind of go that route. So first solve this for z, and you'll see you get z is equal to 12, subtract everything over, minus 4x minus 3y. Now let's let z be equal to 0. So this is one boundary. Z is going to go from 0 to this. Okay. Next boundary, what we let is, okay, so let's just let z be 0, and so that gives us the equation 4x plus 3y equals 12, z 0. And now we're just in the xy plane. And so let's solve this for y. You could solve it for x, but let's just do it for y. So then we get y equals, so we get 12 minus 4x all divided by 3, right? And you could leave it like that, or you could say 12 divided by 3 is 4, and then we've got 4/3 x. So that's our equation. So that's our boundary. Y is going to go from 0 to that. Let's come back to the original. So when z is 0 and y is 0, that's going to give us the x. So then that gives us 4x equals 12. Divide both by 4. We get x equals 3. So that's going to be our last boundary here. And this goes 0 to 4 minus 4/3 x. Okay, so let's go ahead and set it up with some more space. 0 to 3, 0 to 4 minus 4/3 x, and 0 to 12 minus 4x minus 3y. So that's our boundaries. X to the 7th, dz, dy, dx. Okay, and so we go ahead and we first integrate, and so since we're integrating with respect to z, we're doing this one, it's just x to the 7th z. So x to the 7th is like a, you could have started with x, but I guess this maybe is a little bit easier. And then we do our limits from 0 okay, and then we still have our dy dx. So we plug in our limits. The lower limit, when you plug in 0, this all becomes 0. So it's going to be x to the 7th times 12 minus 4x minus 3y. That's our new integrand. You can, before I write everything, I'm going to just distribute it on through. That's 4x to the 8th minus 3x to the 7th y. And you could leave it out, but there'll be a time when you're going to need to distribute it anyway. So let's go with that, dy dx. So the first integration is done. We do the next one, so now we're integrating with respect to y. So everything is a constant with respect to y. So we integrate, this gives us y to the first power, x to the 8th, y to the first power. And then this one is going to become y squared divided by 2, right? So we got minus 3x to the 7th, y squared divided by 2. That's our integration. We go from 0 to 4 minus 4/3 x. This will probably get a little messy. We still have the 0 to 3. We still have the dx back here. But this has been integrated. Plug in 0 for y. That's all going to be 0. Good thing we use that boundary. And then we plug in 4 minus 4x. Now, one thing you could see, we I don't know, we could factor out a y. Is that going to be the better way to do it? I don't know. It's going to get messy any way we do it. Yeah, let's just do it. 12x to the 7th times 4 minus 4/3 x minus 4x to the 8th times 4 minus 4/3 x minus, I'm going to group this 3x to the 7th over 2 4 minus 4/3 x squared. We're going to have to FOIL that out, and over here we're going to have to distribute. And again, we still got our boundaries. I'm not going to write them. I'm going to fix this. So let's distribute through. 12 times 4 is 48 x to the 7th, and then we multiply here. 3 goes into 12. 4 times 4 is 16, so we get minus 16 x to the 8th. It's just, again, tedious. Here we distribute through, and we're going to get 16 x to the 8th. Negative times a negative becomes positive. 16/3 x to the 9th. And then before we do this one, let's go ahead and FOIL this out. So we get 16. We get minus 16/3 x minus 16/3 x, and then the last one will be a plus 16/9 x squared. Okay, so let's do one more step. Let's make it all pretty over here. So we had 16, 2 of those, that's 32 over 3x plus 16 ninths x squared. And then we multiply this whole thing times 3x to the 7th over 2. So it's going to go, we get some canceling. So the first one, 16 divided by 2 is 8. 8 times 3 is 24. X to the 7th. And I guess just to be nice, let's do this as a negative. So it'll be a minus 24x to the 7th. Multiply here. 2 goes into 32. That's going to become 16. 3's cancel. X to the 1st, x to the 7th, x to the 8th. Negative and negative make that a positive. And this last little piece here, the 2 goes into 16. That gives us an 8, 3, and 9. So that's a 3, right? That cancels. And then x to the 7th times x squared is x to the 9th. And there's a negative and a positive, so that's negative. Okay, the first term is negative. 24x to the 7th. And I've already distributed the negative through, so then the rest of the signs just follow through. Minus 8/3 x to the 9th. You can maybe kind of see why we're only going to have so many questions. Okay, so now we got to group like terms. We got an x to the 7th here and here. 48 minus 24 is going to be 24x to the 7th. We have a x to the 8th here, here, and here. So plus 16 and a minus 16 cancel out there. So we have a minus 16 x to the 8th. As far as x to the 9th, and nice they already have a common denominator, we have a plus 16 and minus 8, so that's going to be a plus 8/3 x to the 9th. Okay, and we still have the last integration to do in terms of dx. And so we integrate each of these, so this is going to become 24x to the 8th, add the 1 to the exponent divided by 8, minus 16x to the 9th divided by 9, plus 8x to the 10th over 30, right, divided by 10 times 3. And we take that from 0 to 3. Okay. Looking good. So far, so good. Now we just, again, when we plug in 0 for x, that all becomes 0, so all we really have to do is plug in the 3 and get a common denominator, I guess. Let's see, 8 goes into 24. Let's simplify, I guess, a little bit. That's going to be 3x to the 8th. This one is going to be, that's not going to simplify at all. Let's go ahead and start plugging in. Since we really just need to calculate this, right? 3 to the 8th. It's going to be minus 16, 3 to the 9th over 9, plus 8, 3 to the 10th over 30. Let's just do this with handle that. cancel out a couple of those 3's, right? Maybe that's where that's, because there's a power of 3 here. We can make that a 9. Yeah, I guess let's do that. Let's make it a little easier. This is actually, think of it as 3 squared, so this becomes 3 to the 7th, right? So that takes care of that part. This is 3 times 10, so let's cancel one of these and one of these. That's 3 to the 9th now. The 2 goes into 8. 8 divided by 2 is 4. It simplifies a little bit, and then we'll probably have something in terms of a 5th. Let's back up here a little bit. Let's just do this as 3 to the 7th. And I'm just a little concerned is with the exponents, sometimes you can easily overflow the calculator. So that's why I wanted to, I don't know if 3 to the 10th would do it or not, but this is 4 times 3 to the 9th. Divided by 5 is still there. So I'm going to go ahead and do that. You get that, which is a correct answer, but they're going to want a fraction. So what we do is we hit the math key, and there's a fraction. Let's turn it into a fraction. So it takes the answer, turn it into a fraction. 21/87 fifths. It might take the decimal, but so that is number 16, or chapter 16, number 70. Thanks.